Okay, so once you plot all the dots and you draw your curve of best fit, okay, bear with me here as I try and do that over here. So you should have it something that looks like this. Okay, a curve of best fit. That's going to represent a sinusoidal function. Okay, now we're going to use that graph to try and figure out the equation. So we need our 4 parameters. We need a value, which is our amplitude. Now just by looking at that graph, we won't be able to tell the amplitude because we have a couple of different points. This is where we're going to use the specific points. Amplitude is going to be max minus min divided by 2. So if you look at the data, the maximum point on the data is 7.8. What's the minimum point on that data? 1.4 divided by 2. The amplitude is going to end up being 3.2. Correct? Next thing, we want to figure out the b value. B value is 2 pi divided by the period. Let's see what the period here ends up being. You'll notice that 2 points are going to repeat themselves after. Let's see here. So 2 repeating points that I can find. I can compare this one and I can compare this one. They're roughly 2 repeating points. If I look at the distance between them, what's the distance between them? How many hours? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hours. So period is 12 hours, right? So 2 pi divided by 12 gives me pi over 6. In fact, any of these graphs that you're working with where you're dealing with a tidal graph, the tide pattern is always periodic. Every 12 hours you have the same sort of tide pattern, right? That's why if you ever go to the beach, you'll have a low tide in the morning and low tide in the evening. That's right. It's like a Ferris wheel except it's got a period of 12 hours. Right? Try that sometime. Go to Crescent Beach really early in the morning, 6 o'clock, 7. You'll see how far the water is down towards the ocean. Just stand there for half an hour, you'll see the water just rising. Tide going high. And then come back in the afternoon, it'll be really high tide. Go back in the evening again, around the same time you're in the morning, it'll be low tide again. Water will be further back out again. It's very interesting how that pattern behaves even in real life, sinusoidal. Tide pattern. So we've got the b value. We need the vertical displacement. Again, it's really hard to figure out the vertical displacement just by looking at the graph. We'll be estimating. So we'll actually use the values. Vertical displacement is going to be the midline. The midline is going to be in between all of our data. So I'll find the maximum value, add the minimum value, and then divide it by 2. I'm basically finding the average of the maximum and the minimum value. So the max was 7.8. Plus 1.4 divided by 2, that works out to 4.6. So that means I have a midline at 4.6 roughly. So if I draw that midline out, then at 4.6 I'm going to have a midline right about here. Does it look like that would represent the midline on my graph? Right, do a visual inspection, make sure it actually makes sense. So the midline at 4.6. Now I have enough information that I can go ahead and start writing down the equation of my function. You'll notice that if I want to write this as a sine function, it's not going to be an accurate function. Sine graph starts at the midline. If I want to write that as a sine function, I would be estimating my starting point. Like sine would start here, negative sine would start here. I'd be estimating those values. However, if I want to write as a cosine function, I do have the exact values to work with. For cosine function, it starts at the maximum. I can use the maximum point right here. Or I can use the minimum point right there. Right as a negative cosine function. That's what I'm deciding, which kind of function I want to write it as. and then depending on what kind of function I want to write it as, that's going to be my phase shift. You can write it as any function as long as you pick the right phase shift. So I'm looking at the graph right now, seeing which one's going to be the best choice. Either writing as a cosine or a negative cosine is going to be the best option, because I'm going to have an exact value for the phase shift. My point ends up on one of the corners of the grid. If you want to write it as a sine or a negative sine and sine start here. Notice those points, the x value of those points is not exact. I would be estimating the x value of the phase shift. And I want to try and get an accurate phase shift. So cosine and negative cosine is all write that as. Again, height of tide as a function of time equals. As a positive cosine, I'll get 3.2 cosine pi over 6 brackets t minus. What's the phase shift for positive cosine? 2 hours. So t minus 2 and then plus 4.6. Okay, positive cosine starts here. Normally positive cosine starts at 0 and the maximum, right? But the maximum has been translated to the right by 2 units. So we got a phase shift of 2 units. I could also write that as negative cosine, which would be negative 3.2 cosine of pi over 6 t minus 8 plus 4.6. You also have to notice what the data is representing. It's representing time after midnight, number of hours after midnight. Because I've connected the graph by hand, I know that I may have made a mistake connecting the graph, right? So the intersection points of the midline and where the graph is going from, those could be varied a bit depending on how I've drawn the graph. Whereas the maximum and the minimum points are fixed. Those were given to me. Right? So I want to use the information that's fixed, not the information that I'm coming up with. If I want to write a sine function, I'd be starting over here and starting right here. These points, I am generating them. I'm looking at those points by drawing a graph and drawing a midline. I could have made a mistake drawing a graph. I could have made a mistake drawing the midline. Could have been shifted a few units up or down. Right? So I don't want to make a mistake based on my drawing. I'm going to pick the points that are exact, that are given to me in the data. And the max and the min are given to me in the data. So I'll use a cosine function since the max and the min are given. Okay, all I need is one equation. Doesn't matter what kind I write. So I can use any one of these equations now to answer the next set of questions. So, next up, estimate the tide height at 1615. Give the answer to the nearest tenth of a meter. So one of the first things you'll notice now is it's asking us for the tide height at 1615. What does the 1615 represent? Time in 24-hour clock. Right? 1615 represents time in 24-hour clock. What time does that represent in a 12-hour clock? 4:15 in the evening, in the afternoon, right? 4:15 in the evening. Now, is our graph written in terms of time or is it written in terms of hours after midnight? Hours after midnight. So before I can start evaluating it, I want to convert it into a more relevant number. So 4:15 in the afternoon is how many hours after midnight? Yep. So 16:15 in the afternoon or 4:15 in the afternoon is how many hours after midnight? 16 hours and it's 16 hours and 15 minutes, but I want to have it as a decimal, 16 point something hours. What is it going to be? 16.25 hours. So it's actually going to be 1615 is equivalent to 16.25 hours after midnight. I hope you're able to make sense of that, right? The time 4:15 in the afternoon is going to be 16.25 hours after midnight. So you've got to convert those minutes into hours as well, right? So whatever the minutes were, if I asked you what would be the time 16:20, you would take the 20 minutes, divide them by 60 to convert them into hours as well. So then it would have been 16.333 hours. Now I can go ahead and evaluate that. I want to figure out what's going to be the height after 16.25 hours after midnight. Okay, take that 16.25, plug it into any one of those equations and solve it and see what you get. And once you've done that, the answer you should be getting, and you can verify this, is 5.8 meters, I believe. So try that on your calculator, plug it in, and hopefully we end up with 5.8 meters. And I'll do that over here to kind of show you how to plug this into the calculator. So 3.2 cosine of brackets, another brackets for pi over 6. That bracket close, another bracket for t is 16.25 minus 2, bracket close, and then plus 4.6. Okay, 5.824, so the nearest tenth of a meter is what it wants us to round to. So 5.8 meters is going to be the height after 16.25 hours. Please make sure you're comfortable plugging that into the calculator. If you don't put the brackets in the right place, you're not going to get the right answer. You're taking cosine of that entire chunk, right? Cosine of pi over 6 and the time. So that's got to be in brackets. Pi over 6 is a fraction, so that's got to be in brackets. So you're going to need double brackets here. Are we okay with coming up with that answer, plugging into the calculator? Yes? No? Okay, if you're struggling with that idea, come and see me after the notes. I'll show you how to use your calculator then. One of the other really neat things that we can do, right? And again, this is not really tested. It's not a big portion of your curriculum, but it's really, really neat. We do a lot of this in the Foundations 12 course, is look at data analysis and regression. Your calculator is pretty smart. Your calculator can actually take a look at individual points and try and come up with its own equation of best fit that's going to pass through those points. Right? So the next part says write an approximate equation that represents the curve of best fit for the sine function. So here's how we would go about doing this. Follow along. This is something that's going to take us a few steps. But again, chances are I'm not going to quiz you on this too much. But let's do this. So first things first, we're going to go ahead and enter that data into our calculator. Because the data is a list, in order to enter a list into our calculator, we go right here. So clear, actually reset the calculator. So second memory, reset, all RAM, reset. Just so that we've cleared our calculator memory. This is the data that we want to enter into our calculator. So here's where I'm going to go. Stat, click the stat button underneath the delete button. Okay, and then press edit. You're going to come across a table of values, L1 and L2. In L1, I'm going to enter all the x values. In L2, I'm going to enter all the y values. Okay, x values are 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Scroll over to the right, enter the corresponding y value. With 0, it's 6.3. Number 2 is 7.